So reactivity series, see, if you look at this term, reactivity means we want to find how mostly the metal, even the non-metals, how is their reactivity if we compare with each other? How is their reactivity? And it's a series, means we'll give you a list. Many students understand this list need to be memorized, but we will try to, as I say, as I give you my word, that we will not memorize stuff. So you can remember this series. So we will try to give you in that way. So reactivity series, a series we will discuss, which will help us to identify how will be the reactivity of different metals and non-metals. You see, this is the reactivity series, what we will study in O-level. You see, the most reactive metal is what here?
Potassium.
Potassium. Then
Sodium, lithium, calcium.
Calcium.
Please
read.
Calcium, magnesium, aluminium, carbon, zinc, iron, hydrogen, copper, silver, and gold.
Right. So this is our reactivity series. Okay. You have said already. Can you remember this series? Is it possible?
I did do it in chapters in class 7, but I don't remember now.
Right. What do you think? Any other opinion? Without memorizing, can we remember this?
I guess so. Yeah, we can.
We can. Okay. Others, what do you think? Kritika, can you remember this without memorizing?
এখানে একটা মেথড আছে, I guess, like first letter গুলা collect করে।
Oh no. ওইটাও memorizing, ওইটা তো আমরা যাব না, ওইটা না। Afrin, is it possible to remember without memorizing? Afrin?
Yes, sir.
Is it possible to remember this without memorizing this series?
In the periodic table, the ones that come first, like that.
Okay, very good, fine. Okay, right. We'll try to pave a way out. How we can remember without memorizing? You see, if you look at properly, let me do in the periodic table the whole thing in the periodic table. See, this is our periodic table. Not only the elements given in O levels or in this list, we can make a bigger list with that. How? If you look at the metals, you see potassium is most reactive. Potassium is the top one. So where is potassium? It is in group 1, right?
Yes, sir, group 1.
If I give numbers, roll number, reactivity number, potassium is 1, sodium is 2, lithium is 3. So potassium is most reactive, then sodium, then lithium. I'm seeing a pattern here. What is the pattern? As you go down the group of group 1, number 1, first pattern is group 1 is most reactive. And as you go down the group, the reactivity increases, right or wrong?
Yes, sir.
Please respond, everyone. Do you understand this?
Yes, sir.
আচ্ছা, অনেকেই ছিলে না, আমি আরেকবার হচ্ছে তোমাদের ইয়েটা দেখাবো, মার্কসটা দেখাবো। And for I expected more from number 1, Tahara. She didn't answer, Tahara didn't answer many of the questions, and I'm not satisfied. Ifat also didn't answer many questions, didn't attempt even, and Taiba as well. Taiba should do much better. It's 80 marks question, and Taiba got only 37. She has much better understanding. 62 is highest mark, and there was 60 and 61 as well. So Taiba could get at least around those marks or more than that. So please, yeah, when you give exam, please give it properly. Huh? So don't neglect. I'll try to take after one episode, I take one test. So try to give them properly. Huh? Taiba, what is the problem?
So to be honest, I wasn't prepared.
No, it's not preparation. It's not your preparation. It's your laziness. I know, because you have much better understanding. Okay, let us go back. Yeah, তোমাদের script gula I gave in the Google Classroom. Download and see, and mark scheme and question paper is also given with that. So just check them. Okay, so as I am saying, if you understand, the most reactive metal from the whole periodic table is what? Which one? Can you tell me? Which one is most reactive?
Francium.
Francium. Very good job. Very good job. Francium is most reactive. So if we remake our periodic reactivity series, it will be like this. See, francium is most reactive, and group 1 is most reactive among other groups. So this is 1, this is 2, this is 3, 4, 5, and 6. You understand? So if we have the periodic table in the exam hall, do you need to memorize it? Which one is most reactive in group 1?
No, sir.
Thank you. Thank you. So after group 1, group 2 will start, and group 2 will follow the same pattern. Group 1 is more reactive than group 2, and group 2 will follow the same pattern. So radium is 7, barium is 6, sorry, barium is what I'm saying, 7, then 8, then strontium is 9, reactivity calcium, if you list it down, then you will write francium, cesium, rubidium, potassium, sodium, lithium, then radium, barium, strontium, calcium. Then 11 is magnesium, and beryllium we don't discuss because it is a very poisonous thing, and it's very unstable element. That's why we don't discuss regarding beryllium, and you will not find beryllium chemistry discussed in O levels and A levels. So do we need to memorize these two? No, thank you. Then after group,
এক্সামে দেয় না আমাদের।
কি দেয় না?
আমাদের এক্সামে একবার মনে হয় পিরিয়ডিক টেবিল দেয় নাই, এমনি টেস্ট মারে পিরিয়ডিক টেবিল ছাড়া।
কোন স্কুল?
স্যার মাস্টারমাইন্ড সাবজেক্ট টেস্টে দেয় না মাঝে মাঝে।
কেন দিবে না?
দেয় না, ফার্স্টে তো আমাদের মুখস্থ করাইতো 20টা।
That is inexperience of the teacher, and if the teacher doesn't he or she is a problematic teacher. I'm saying he want to make your life difficult.
খালি বলে মুখস্থ করো।
I don't know, I don't want to comment. Okay, thank you. So what you need to understand is this periodic table will be given in your exam hall in Cambridge and Edexcel curriculum, and even in IB curriculum. This periodic table will be given, and this periodic table is being given to make your life easy, not difficult. Okay, so group 1, group 2, then group 3. So group 3 will start in this way again. So it's 11, then 12, this is 12, 13, 14, 15, and boron is a non-metal. Boron is a non-metal. So we are discussing regarding metals. So boron we are not discussing. Is it clear? Do you need to memorize?
No, sir.
আচ্ছা, এখন তুমি তোমার ইয়েতে যাও, পিরিয়ডিক টেবিলে যাও। এই যে দেখো, আমি এতক্ষণ যেগুলো ডিসকাস করলাম, এই যে গ্রুপ 1, গ্রুপ 2, গ্রুপ 3, দেখো first three elements are group 1, potassium, sodium, lithium, and you know more than this already. These are group 1. Then calcium, magnesium. Calcium is below in the group and magnesium is above. So that is how it goes. So you see potassium, sodium, lithium, calcium, magnesium. How will do? You see here, potassium, sodium, lithium, then calcium, magnesium, then you see aluminium, group 3. So these are the 6 elements present in group 1 and group 1, 2, and 3 in your reactivity series. So this one, aluminium only, is group 3. Then you see carbon, it's a non-metal, you know, right? Non-metal. And you see we have a bracket here. Why we are putting this bracket? We have a certain objective regarding this, and we have a whole chapter chemistry. Just in that chapter, we will explain why this bracket is given in carbon. Do you understand what I'm saying? But the reactivity of carbon lies here. They are separating group 1, group 2, group 3 metals with the transition metals. You see, zinc and iron, these are transition metals. Transition metals. Zinc and iron. You see in the periodic table, zinc and iron. You can clearly remember how is zinc and iron, because we will study galvanizing later on. Galvanizing. So we galvanize many things, including different iron bucket, and then car bodies we sometimes galvanize. In galvanizing, what we do? We know iron rust, so we give a layer of zinc which will protect iron metal. And why we are using zinc? Because zinc is more reactive than iron. Okay? So when we will discuss that, you can easily remember that zinc is more reactive than iron. And then again a bracket, hydrogen. And this one, hydrogen, is again a non-metal. And why this bracket is given? This will be discussed in electrolysis chapter. Electrolysis. And why we have
are most electric devices galvanized, or are most electric devices galvanized? Or
what I don't understand your word.
Are most electric devices galvanized?
Most electric devices.
Yes.
Yes. Electric devices can be galvanized, but there are other plating. It's not. It is not called galvanizing, because galvanizing is a specific term for coating with layer of zinc. But what you are saying is electroplating. Electrical devices we sometimes electroplate, and galvanizing is a layer of zinc by which we coat. Yes, with zinc we do that as well. If it is coated with layer of zinc, then it is galvanizing. That's true. So do you understand up to this? Hydrogen and carbon, in these two we have brackets. Non-metal, carbon is a non-metal. We'll discuss this in extraction, metal extraction chapter, metal extraction chapter. And why we gave bracket in hydrogen, we'll discuss in electrolysis. Okay, Frida.
Got it, sir.
Okay, and then see, you have copper, silver, gold at the bottom of the reactivity series. Copper, silver, gold, and these three are jewelry. What are they?
Jewelry. Sir, diamond is also a jewelry.
Wait, what?
Diamond is also a jewelry, right?
But diamond is non-metal. And
yeah, that's the fact. Yeah.
Right. But what I'm just saying, so that you can remember the bottom three, which are below hydrogen in the reactivity series, namely copper, silver, and gold. We use them in jewelry industry. Gold and silver are alloyed to make jewelry. Silver and copper are alloyed to make silver jewelry. And sometimes copper and gold are alloyed to make gold jewelry as well. So copper is used as copper is cheap and very much unreactive for alloying silver and gold jewelry. So, and moreover, copper, silver, gold, you can easily remember how. You see, these three jewelries are in the same same vertical line, same vertical position. So see, in the transition metal, copper, silver, gold, serially given. So you can easily remember. So these three metals are below hydrogen in the reactivity series. Take a set. বোঝা যায় একটু একটু?
Yes. Yes, sir.
এখন আমি দেখি একজন ট্রাই করো, দেখি পারে নাকি। তাইবা,
স্যার মুখস্থ পড়া দিব নাকি আমি বুঝতে পারছি মোটামুটি, মানে
হ্যাঁ।
ওই বোঝাটা দিয়ে পড়া দিব?
হ্যাঁ, জাস্ট দেখে দেখে, পিরিয়ডিক টেবিল দেখে দেখে একজন বলবে, দেখি পারে নাকি কেউ। তাইবা, can you tell me what is the first metal in the reactivity series? Don't see your book. If you don't cannot say, no problem, but try. What is the first metal in the reactivity series?
Sir, is it francium?
Which one? Francium.
Yes.
Francium, fine, but since rubidium, cesium, francium, these things we don't use in lab, we start from potassium. So potassium is the first one. Then second,
Sodium,
sodium. First, go on.
lithium.
Lithium. Then next, these three we don't
Third
discuss.
is-
This
And then calcium,
calcium,
magnesium,
magnesium, beryllium we don't discuss because it is poisonous and very unstable. So that's why we don't discuss beryllium. So in group 3, we don't discuss these 3. We have only 1. So aluminium is 6. Fine. Fine.
Yes.
Is it fine?
Then
Okay.
the carbon comes, right?
Okay. After aluminium, what is the next element in bracket? Taiba?
Sir, could you repeat? I couldn't hear you. clearly.
After aluminium, group 1, group 2, group 3 done. So after group 3, what is the next element which is a non-metal? মানে আমরা দুইটা এলিমেন্টকে ব্র্যাকেটে দিছিলাম, non-metal দুইটাকে। ফার্স্টটা কি ছিল? Can you recall?
No, sir.
Anyone?
The non-metal carbon.
Carbon, very good. So carbon is 7. Next, after carbon, we have two metals which we use in galvanizing. That we coat with one metal with another metal. What are they?
Iron,
Iron and
aluminium.
no, aluminium is done.
Zinc and iron.
Zinc and iron, very good. 8 and 9. So iron first, sorry, first zinc, then iron. First zinc, because zinc will be coated. Zinc, we will coat iron with zinc. So zinc is more reactive. So this is 8 and iron is 9. Then what we have another non-metal. What is that in bracket?
Sir, electrolysis.
No. What?
Hydrogen.
Hydrogen. What is the non-metal? Is hydrogen. 10, right?
Yeah.
Below hydrogen, we have 3 jewelry. What are they?
Copper, silver, gold.
Okay, copper, silver, gold. So copper is 11, silver is 12, and gold is the most unreactive element. So it's 13. So these 13 elements are present in your reactivity series.
Sir, we also do have to make it in the order, like order ভাবে মনে রাখতে হবে, right?
তোমাকে এটা কেউ এক্সামে বলবে না যে write the reactivity series. That will not be the question.
Yeah.
And we will
Oh,
practice
okay.
so many times then you can easily remember. So see, you have already said serially these 13 elements, right? So if you practice for next next few chapters, then you can easily remember, I think. So it will not be difficult, inshallah. So that is it. This is the reactivity series. Now, what is the utility in our life, in humans' life? Say for example, if someone is stronger than other, say if we give example, say for example, say Ayman Mahdi is stronger than say Iftikhar. He is stronger, he know martial art maybe. So Ayman Iftikhar is sitting on a chair. So Ayman want to sit on that chair. So Ayman is giving him a punch and displaced Iftikhar from the chair and sit on that chair. So that happens in our real life.
Displacement reaction.
Displacement reaction আমরা ডিসকাস করতেছি। What happens যে আমাদের লাইফে কি হয় যে someone who is stronger can displace the weaker one, right? So the same thing goes for the elements and whatever we have discussed in terms of reactivity series. So the more reactive metal can displace the less reactive metal from a compound. You see here, magnesium is a metal and copper oxide is a compound. You see in copper oxide we have copper present. So which one is more reactive, magnesium or copper? Magnesium. So magnesium, since is more reactive, magnesium can kick out copper from its compound, and see copper is kicked out and magnesium took the position of copper and formed magnesium oxide. These reactions are called displacement reactions. Informally you can say kick out reactions, but don't write in your copy, just to remember. But in descent term we can say it's displacement.
I don't get the point. Can you make sure again?
Who is this?
Sanimran.
Okay, you tell me, we have magnesium and a compound of copper, which is copper oxide. Do you understand? We are reacting these two together. So in this reaction, what will happen? Which one is more reactive, magnesium or copper?
Magnesium.
Magnesium is more reactive. We have already seen, because magnesium is in group 2,
Yeah.
but copper is below hydrogen. So magnesium, since it is more powerful, is more reactive, it can displace copper. And copper is replaced, you see, copper is thrown out, and magnesium took the place of copper with oxygen and formed magnesium oxide. Do you understand?
Okay.
Do you understand? Okay,
Yes,
now
sir.
tell me, if we do the other way around, say magnesium oxide is reacting with copper, then what will happen?
It will stay the same.
Stay the same means?
Like, yes, copper is like less reactive, so it will stay the same because it's already with magnesium.
Will there be any
It
reaction?
will, it will stay the same. Oh, that means no reaction. Okay.
No reaction. Very good. So if in the question paper they say something like this, say a metal is given which is more reactive, and another metal's compound is given which is more reactive, and a metal is given which is more reactive than that.
So
then
can you visualize the no reaction?
Again,
So could you repeat? Visualize the no reaction.
which one I'll repeat?
No reaction.
No reaction one.
No reaction one. See,
That
copper
can
is
you-
less, since copper is less reactive than magnesium, copper will not be able to displace magnesium because copper is less powerful. So magnesium is more powerful. So the less powerful element, copper, cannot displace a more powerful element from its compound. So there will be no reaction. But magnesium was more powerful, so it displaces the less powerful element from its compound. Do you understand? Do you understand, everyone?
Yes, sir.
Okay.
Yes.
Aman, do you understand?
Yeah.
Aman,
Yes, sir.
Sadika?
Yes, sir.
Okay, fine, thank you. Acha. If I write more reactions here. So if you know the principle, you can write thousands of reaction now, thousands. You see, let me write. Say for example, sodium plus potassium oxide. Ifat, can you tell me what will be the product? If which one is more reactive, sodium or potassium?
Potassium.
Potassium. So what will be the product of this reaction? Ifat, will there be any reaction?
Yes, sir.
Yes. Sodium is, you said potassium is more reactive. Sodium can displace potassium?
No.
No, so there will be no reaction. We understand.
Yes, sir.
But if it is other way around, say potassium plus sodium oxide, then what will happen?
There will be a reaction.
And what will be the product? What will be the product? Isn't it very easy? Ifat?
potassium oxide plus sodium হবে না?
Exactly. Potassium oxide plus sodium. And we need to balance the equation. We have 2 sodium here, so 2 sodium, and 2 potassium here, 2 potassium. So see, whatever we have discussed in language part, these things are coming now. You need to apply, because they will ask you to write the reaction. Again, see, if we go on, if we proceed, okay, one thing. From the Pearson book, displacement reaction is in chapter 14. It's in page number 145. Please note it down. Okay? And we will cover both books. Okay? From the Cambridge book, what we have discussed is in 7.1, we didn't enter oxidation reduction yet. After finishing displacement from Pearson book, we will enter oxidation reduction reaction. ঠিক আছে? So this thing you need to take 7.1. Okay? Just take the note. 7.1 from the Cambridge book, and from Pearson book, it's 145 page. Okay, next point to see. If we proceed, there are many examples given. See, magnesium is more reactive than zinc. So magnesium will be displaced, will be able to displace zinc from its oxide. So you see, magnesium oxide is formed and zinc is displaced or kicked out. ঠিক আছে? বোঝা যায়?
Yes, sir.
Response from others, please.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, thank you. Thank you. Again, see the next one, carbon, graphite. Whenever you will find carbon, you will understand it is graphite. So graphite, carbon plus copper oxide. You know, carbon is more reactive than copper, so carbon will be able to displace copper. So carbon dioxide is formed. So it is, carbon is taking the place of oxygen. So taking the place of copper, and copper is kicked out. You see, copper is kicked out because copper is less reactive than carbon. So that is how it goes. And oxidation reduction will start after that. But before we go, we can give many other examples. We have less than 1 minute. You come back, then we will start, inshallah. And I noticed many students do not join after in the second episode. So please rejoin.